Hello students, I hope you are doing well during this lockdown conditions and you are safe along with your family members. Children, I am here with another video based upon the topic called refraction. In the last video, we were discussing what is called Snell's law. Snell's law, without any formality, we can start the proceedings of the video, right? So we are starting with what is called brief revision of Snell's rule or Snell's law. Children, you know, this is supposed to be a glass slab. This is the ray, incident ray will bend towards the normal and I, this angle is R. So in the last video we have done the refractive index is basically defined as sine of I divided by sine of R. This is what is called Snell's rule or Snell's law. Alright? Till this point we have done things in the last video. Now I start giving you another important concept as far as the refractive index is concerned, what is called absolute refractive index. Children, we know very well the biggest fact about all electromagnetic waves or light waves that in the air or vacuum they travel with the speed of light, which is represented by C. It is 3 into 10 to the power 8 meter upon second. So children, if you fix medium number 1 or medium number A, this is supposed to be medium number A, supposed to be medium number B. Children, if we fix this medium number A to be air, this is supposed to be air. And this could be any other transparent medium, maybe glass, maybe water or whatever. So children, when the ray travels from air to any other medium, then the refractive index of that medium number B I am talking about, is called absolute refractive index. Alright, I repeat, when the medium number A or when the light ray travels from air to any transparent medium, then the refractive index of that transparent medium is called absolute refractive index. And it is, you know, formula mu is equal to absolute refractive index is defined as C divided by V. What is C? C is the speed of light in air. Its value is 3 into 10 to the power 8 meter per second. And V is the speed of light in that transparent medium. Here, suppose it is the glass slab. Let us take the speed of light to be V here. Then mu is equal to C upon V. Now let us come to another important thing. What must be the SI unit of refractive index? Absolute refractive index. Children, this is speed meter per second. This is also meter per second. So remember, it has no units at all. It is just a constant quantity, unitless quantity. One other thing, mu is more than 1 or less than 1. The answer I am giving you, children, because C is always more than V. Remember, the speed of light in air is maximum. In some other medium, the speed of light is lesser than C. That is 3 into 10 to the power 8 meter per second. So children, it is a mathematical fact. When numerator is more, denominator is less. So answer will be coming out to be more than 1. So always remember, mu is always more than 1. Because C is always more than V. So this is the basic thing of what is called absolute refractive index. So before moving ahead, a simple question is coming to my mind. What is the basic difference between relative refractive index and absolute refractive index? I must give you the answer also. Relative refractive index means when the ray of light moves from any medium, any other medium, any transparent medium to other medium. For example, when the ray goes from A to B, then it is called the refractive index of B with respect to A, relative refractive index. And it is represented by what is called mu of B with respect to A. So remember, when the light goes from A to B, it will be the relative refractive index of B with respect to A, and it is sin I upon sin R. Alright, what is relative refractive index? If we fix medium number A to be air, then the refractive index is called absolute refractive index. Fine, let us move ahead. Children, there are some basic formulae, some basic concepts which are involved in the concept of refraction. Let us go ahead. So the first is what is called the principle of reversibility of light. Principle, I repeat, principle of reversibility. For example, this is supposed to be the glass slab, medium A, medium B. The normal, the ray is coming and bends in this manner. This is I and this is supposed to be R. Children, this is mu of B with respect to A is always equal to 1 upon A with respect to B. What is the meaning? I take one example. For example, A is glass, water may be water, and B is glass, G. So remember, as per the principle of reversibility of light, mu of glass with respect to water is always equal to mu of water with respect to glass. Children, a simple proof is there. I shall be giving you the simple proof in form of the notes on our group. Alright, so try to prove this. This is an important formula in physics. That is, I repeat, the refractive index of glass with respect to water is equal to 1 upon the refractive index of water with respect to glass. You have to be ready. Any numerical can come based upon this formula and all. Alright, this is another important concept. Let us go ahead. Another important concept is, if you consider a compound slab, that is 3 media I am talking about. For example, I make another diagram for you. I make necessary correction over here. This is suppose medium number C. Children, the ray is coming initially medium number A, medium number B, and medium number C. So the ray is coming from A to B, B to C. Let us make normal over here. It goes in this manner. Once again the normal, it is going here. So let me just explain to you the basics of this diagram. The ray refraction is taking place at 3 different places. When the ray is going from A to B, from B to C, and finally from C to A. Once again, this is medium number A. Remember children, for this case, I am writing the simple outcome. I write here, this is mu 3 times, you just write down mu is equal to 1. It is AB, BC and CA. So this is for the sake of your convenience, you can comfortably learn this formula. If I write in this manner, this is the mu of B with respect to A, this is mu of C with respect to B, this is mu of A with respect to C is always equal to 1. Remember this formula. As far as the proof of this formula is concerned, once again I am telling this simple proof I shall be giving you in form of the notes later on, right? At the beginning of group. Now let us further manipulate this formula. Children, from this formula we can see mu of C with respect to B will be equal to 1 upon mu of A with respect to C into 1 upon mu of B with respect to A. Now children, we are comfortable, we want every refractive index has to be with respect to air or vacuum. So we are comfortable with this term. This term is the refractive index of B with respect to A. But it is the refractive index of A means air, if it is air, with respect to C. So this can be changed, this can be replaced by, because 1 upon mu of A with respect to B will be equal to mu of B with respect to A. So we shall be having therefore mu of C with respect to B will be equal to mu of B with respect to A divided by mu of C. This is supposed to be C. I must write C over here. I must write C over here. So this is going to be C and this is B with respect to A. Alright. This becomes an important formula. I just take one example. For example, you want to know what is mu of glass with respect to water. You are given 2 refractive indexes. For example, you are given the absolute Ri of glass and you are given absolute Ri of water. Then the refractive index of glass with respect to water will be absolute refractive index of glass divided by absolute refractive index of water. Alright. Number 1. If you are given another question, find out mu of water with respect to glass, then it would be just mu of water absolute divided by mu of glass absolute. Alright. So children, this is number 2. Remember, the refractive index which we are supposed to find out is always kept in numerator, and with respect to what is taken, always taken in denominator. Alright, this concept must be now clear. This formula is important from the point of view of numericals. Alright, let us move ahead. Let us discuss another important concept of refraction. Children, what happens when the refraction takes place from a parallel glass slab? That is, the two faces, I just make a glass slab. Remember, these two faces are just parallel to each other. Condition number 1. Condition number 2, these two media, they are same. Suppose A, B and A. I repeat, this is A, this is B, this is once again A. For example, air, glass, once again air. And these two faces are parallel to each other. So remember children, no separate proof is required. From the simple geometry you have done in 10th standard, we can easily conclude. Let me just make the diagram for you. This is incident ray, this is normal, will bend and will go away from the normal like this. So children, when the ray goes from A to B, this becomes angle of incidence I, this becomes angle of refraction R. Now, see it, be careful in watching this step. This is going to be, if it is R, this will also be equal to R, and this is I, then this will also be equal to I. So always remember, this condition will be fulfilled when these two media, they are same. For example, air, glass and air. These two media, these two angles will always be equal to each other, and these two angles will always be equal to each other. Children, let us come to another important concept of refraction. That is what is called, if you stand in front of water. For example, you are going and you are standing in front of a swimming pool. If you look into the water, it will just appear as if it is 1 or 2 feet depth wise I am talking about. But as a matter of fact, when you go into the water, you will feel it is 6 feet deeper or 7 feet deeper and all. So this is what is called optical illusion, and it is basically due to the concept of the credit goes to refraction only. So we shall be discussing all these concepts in our next video. Thank you so much. Stay safe, stay healthy.